you to go ahead and just pick two 2x2 matrices A and B and try and make them as random as possible. What's AB and what's BA? I'm going to give you a moment to go and compute that. So come back, pause the video, come back when you are done. Alright, so now that you're back, it's very likely that you found, very likely, I can spell likely, likely, you found that AB is not BA. Now sometimes you'll be lucky and you'll get that AB is BA, but for most choices of A and most choices of B, A times B is not B times A. Unfortunately, matrix multiplication is not commutative. Luckily though, most of the expected properties do hold. In fact, we have a theorem! Alright, so here's this theorem. So here I have three matrices A, B, and C, and I have a scalar k. This first guy here, this tells us that matrix multiplication is associative. And here, distributivity works just as we'd expect. And it doesn't matter in which order we do the scalar multiplication or the matrix multiplication. Now you may have been wondering before why I called the matrix I sub n the identity matrix, and that's because of this part E. When I do this left multiplication here, I get back A. On the right, I get back A. It gives the identical matrix that we started with. It's the identity. So let's do an example. If A and B are both n by n matrices, is the square of A plus B equal to A squared plus 2AB plus B squared? So if A and B were numbers, then this would be true. So let's see, is it still true for matrices? Well, let's go and we'll calculate the left side and see if it equals the right. A plus B squared is equal to A plus B times A plus B. Then distributing this A plus B to A and to B using C, so that's C part here, we get A times A plus B plus B times A plus B. You have to be very careful when you're working with matrices to preserve the order of multiplication, because as I said earlier in this video, matrix multiplication is not commutative, so order matters. Then using part B, the distributivity on the left, we get A times A, so A squared, plus A times B, plus B times A, plus B times B, or B squared. So A plus B quantity squared is equal to A squared plus 2AB plus B squared if and only if, so this double arrow symbol means if and only if, A squared plus AB plus BA plus B squared is equal to A squared plus 2AB plus B squared. But, okay, but if this thing is true, well, I can cancel out this A squared and this A squared and this B squared and this B squared, and I can take one of these, I can take this AB and cancel out one of these ABs on the right. So this is true if and only if BA is equal to AB. In other words, it's true if and only if A and B commute. So the answer here is no, unless A and B commute. Note, by part E here, IN, so the identity matrix, so if A is n by n, then in times A equals A times in. So in other words, the n by n identity matrix commutes with every n by n matrix.